Right. Time for some on-stream soldering again. No real plan for today. Just chip away at the little jobs for keep talking game. I'll probably make a big mess, but we shall see. Right. Really should take this down, even though that's going to be a pain to manage. So I am doing the little shift register breakout boards at the moment. Probably good. So these boards will be used in things like the needy modules when for controlling the 7-segment display. So I'll just do 2 at the moment, which will be a good demonstrator for that. I decided to do this by hand as well because I don't have a stencil for this board and it's hard to control how much solder is going onto it. Let's try and get that lined up a bit better, that's pretty good. Right, now let's get this, the rest of this soldered on. Hello, I too like a game. Thanks for dropping in. Happy to give a bit of an explanation, but oh no, that's way too much solder. What's happened? Got distracted. Happy to explain, but if you're not much into electronics or anything like that, that's fine. Just come and hang out. Nice to have returning people who have watched the videos and are interested in it. It's honestly been the one thing that's kept me going in all of the long time that I've been doing this, is the interest and support from commenters. Okay, great. So no fun demonstrations this time, probably, in terms of hooking stuff up to the bomb, but we shall see. I don't know how well those are attached. And it just doesn't seem like the pin's actually attached to the base, but okay. I'll trust that's okay. So each of these little chips basically can write 8 signals, high or low. And if you think about, yeah, totally. I mean, it's been difficult at times because it's been a long time coming and a lot of difficult and quite fiddly parts to design and build, and also challenges, how to do a lot of learning to make all of this come together and work, because I'm not an electronics expert whatsoever. So you know, it's definitely been keeping me going through the harder parts of the project. But yeah, I was explaining the chip. The chip has 8 outputs that it can control, and then if you look at the 7-segment display, oh, maybe I should use this camera. Each digit has essentially 8 bits, so it's a perfect little chip to control these boards. So if I make a bunch of these boards, which I've designed to kind of slot into each other, I could take that board that you just saw with 2 digits, and 2 of these chips could control that, or 1 chip even. Okay, my dog is getting wound up as well, but I don't think it's going to hassle me too much. Just want a bit more solder on these. That looks a bit messy, but it's working. Tidy that up a tiny bit. Okay, that's good. So I'll finish the rest of this and then do the tests. So I'm just going to make a couple of boards and then test out a new 7-segment display with that, see if it all works. I know, right? If you told me it would take 5 years to get this far, I would have maybe thought again about doing it. Yeah, I mean, well, it's been 5 years, but it hasn't been a solid 5 years. It's been me trying to, do little bits here and there when I've got some free time. So, yeah, probably not all that much time in total, but yeah, it's just been really interesting though. I mean, it's learning a lot. I like learning, so that's kept me going in part. And then, when you get a new module working or whatever it is, that's another kind of big morale boost in terms of, yes, I can do it, and it's it's starting to come together. Yeah, that's really good. So it's all been fairly easy to keep it going. Okay, so just got 1 capacitor and 5 resistors to put on the board as well. Should be pretty simple to do. There we go. Everyone needs a hobby, yeah, and this has been amazing. I haven't had a hobby that I've been into quite this much before. I've had gaming or whatever, music that I've enjoyed, but this is kind of a whole new level of always thinking about that, always wanting to plan the next bit, and if I don't finish a part that evening, I'd be thinking about how do I finish it, and yeah, it's really occupied a lot of my brain space, so haven't had much like it before. My tweezers are absolutely trying their best to keep hold of this little capacitor as well. Oh my god, please stop grabbing it. Let's do it this way. It must be static or something keeping it on. Right. Perfect. I explained the chip a little bit. It's just a chip that can write 8 output lines for the 7-segment displays. Come on. There we go. So these will plug into, if you've seen the kind of module PCBs that sit in the back. So these chips can plug into these. and then I can wire that to 7-segment displays to control them, which I'm hoping to do this for my needy modules, because they've got the timer at the top, which I don't have at hand, but I've kind of got venting gas working apart from the segment display. So I got a new segment display that's easier to drive than the old one. So I'm preparing some chips, and then as soon as these chips are done, and I wire it to the display, venting gas is essentially done. So yeah, that's the goal really, because I've got it all printed, got most of the electronics done apart from this one bit, so I wanted to get that one done and dusted. One, 2, 3, 4, 5, 6, 7, 8 resistors. Okay. How much of the project have you been following, out of interest? Most Likely Tinsons came out and some across the channel about a year ago. I binged all the videos. That's really nice to hear, to be honest. No, that's really good. Yeah, I don't know what to say really. I'm not used to much attention, to be honest, because it's quite a niche little project. I don't imagine too many people will be interested in it if they don't know the game. And I'm not much of a electronics person, so there are more experienced people for that kind of thing. I know, and for the past kind of 3 years or so, I've been saying that it'll be done this year, and then something's happened to stop that from being true. But I honestly do think it will be finished this year. Really, because I've got a lot of the modules done. Like the module boxes are all bolted shut. They're ready to roll. So honestly, I think it'll be done this year, or at least most of the modules will be the ones that I've been planning to do. As obviously some of them are quite difficult to make working for real. Okay. Wait a minute. So for those, the widget microcontroller and the widget board basically just picks anything from random, and the other builders had kind of, I think some had decompiled the game, or otherwise just played so many games that they roughly know the likelihood of the number of batteries turning up or whatever it is. So it should be a fairly accurate generation to the game in terms of the things it suggests to use to plug in should be the right kind of frequency that happens in the game. Oof, come on. There you go, that's better. And then, you know, things like the widgets are randomly generated by the game because there's not that much thought goes into it. The player selects the modules they want themselves. You just plug them in and the game knows what's being plugged in and will play that game rather than it suggesting what modules to plug in itself. That's completely user defined. And then for something like, you know, wires module, the microcontroller will tell you what wires to attach. So again, it kind of, and the reason I did it that way, because a lot of the other builders are doing it that you put the wires on, and then you tell the controller what wires are there. So it's driven by the user, but I don't want the user to really influence what happens. I think the computer, the microcontroller, should tell you what's attached, and then you play that game. So it's randomized. You can't kind of gear it towards, well, I'm used to doing a 6-wire module, so I'll put 6 wires in. Stops you from kind of controlling what the game looks like. But that's all up in the air because a lot of that stuff I wrote years and years ago when my coding wasn't quite as good, and it works, but you know, I could return to that later and, you know, give the user more control over it or less control or whatever it is. Yeah, it's not set in stone. Oh my word. God, I just cannot hold my hand in the right place for this. There we go. So I hope that answers the question. I'm trying to flip this resistor over, but it will not flip over. There we go. Well, it depends. Again, you know, people are naturally good at some things and not others, but I really think that coding is not as intimidating as it is. You know, I think a lot of things are written for people who already do coding in mind, and it can be quite difficult to start from that respect. But I honestly think if you had, you know, a good teacher or a good, I don't know, reference material, you could pick it up, I think. But then I say that with a strong mathematics background, so maybe I'm wrong on that one. I mean, some of the stuff is quite complex that I am doing, the electronics coding. But you know, if you take a simple module again like wires, which is a good exemplar, the manual is essentially written like the code. You know, if third wire is blue, whatever. So it's just a series of if statements. That's a pretty simple module to do. God. Got so much solder going on here. Yeah, totally. I mean, again, the PCBs, like I've designed this little PCB. It's nothing exciting, nothing to really talk about. But you know, I didn't know you could do that. I didn't know there was free software that could let you do it. And then again, it's not just using the software or finding the software. It's all right. How do I make a PCB? I have no idea. You know, I did some baby electronics courses, but you know, years and years ago when I was in school, but nothing like you'd need to do it. But again, it was actually fairly simple. A couple of little rules, watch a few people make videos on the subject, and you know, there's seriously plenty to learn on it, but to make a little beginner PCB like this, which you know, only really does one simple thing, it's actually surprisingly simple. And just like that, we've got the first, that's not focusing. Brilliant little webcam that. We've got the first PCB there. Can't see it at all, but that should be fine. A little scrappy, but this is more of a test than anything else. Now what can we do? I can do the second one. I think I'll just do the second one and then think about connecting it to the display to test. Wow, there we go. Soldiers really want to stick into my iron rather than the board. Okay. Which way do I have the dot? Bottom right. Bottom left, sorry. Outside bomb making? Well, this has taken up a lot of my free time, to be honest, and I'm really pushing it through. I mean, like I said, I play music, but I haven't really picked my instruments up in years, to be honest. Yeah, and that's it really. I mean, if I've got free time, if I'm not just enjoying myself, you know, playing games or whatever, I'll be doing this. This is my main hobby now. Ooh, I'll start here. Word, come on. No, that does not want to stick. Yeah, I suppose so. A lot of bits to it. Printing. A lot of it's obviously sat at a desk or at a computer specifically, but yeah. Knew I'd do that. Oh, come on. It's quite nice. So what happens when the solder's sticking to my tip rather than coming off? Right. Right. Don't really want to use wick, but I'm going to have to, I think. Oh my word. Brilliant. This tape is not strong enough. Right, hang on. It's not too bad, and it shouldn't take a lot of time. I've just been a bit careless, to be honest. I'm just trying to get it done quickly. The amazing thing about soldering is that the solder sticks metal to metal, and if you've ever seen reflow soldering, I mean, you can see that the parts are literally pulled by the solder to where they need to be. It's amazing. It's like magic. So not really. You just need to be close enough. But yeah, it's just carelessness. That's the only reason I've done this. I've still got a bridge. Come on. Usually a dry iron will want to suck the solder back off it, but it's not really working for me for some reason. Right. I need to clean my tip here, so there we go. Clean tip. Although this is okay. I think it's actually stuck together now. But no, you don't need steady hands at all, really. Again, it's not as hard as it looks. Tidy that up. There we go. And back to it. It's still trying to stick to my soldering iron rather than go onto the pin. There we go. See that just sticking to the end? There we go. No, I don't stream a whole lot, to be honest. I've only been doing it a bit more recently because a lot of these tasks, as you can tell, are pretty dull. Just a lot of crimping cables and soldering little bits and pieces together. It's a bit dull, so it was just something that breaks up that monotony, makes it a bit more interesting. And it's not great making silly mistakes in front of people, but again, I don't get too many people viewing. Right, come on, there we go. Might nudge some of these lights, it seems quite dark on this board. Oh, that's a lot of solder. Again, these aren't going to win any awards for the soldering on these, but they just need to work. Okay, that looks good. Well, I don't mind admitting my mistakes, it's the only way to really learn, but as I was saying in another stream, I don't solder all that often. I usually do a lot in a batch, but that means that I don't learn very well because I'm not doing it very often. Oh, right. I know. Again, I freely admit that I'm still a relative beginner with this sort of stuff anyway, so you know, it's what's to be expected, to be honest, I think. Absolutely happy to admit that. Great. That went on pretty nicely. My soldering iron is not looking healthy. There we go. It looks really, really corroded under the microscope. Oop. Right. Just a little dab of solder on each part, and that helps the resistor stick. After this, I don't know, there's a lot of other electronics projects that I've seen others make that have got me interested, but I think I want to put it all down for a while. I mean, I've been thinking about this kind of stuff for a long time, so yeah, maybe something else like music or whatever, or something else that's kind of crafty. But if it was to be electronics based, I'd probably do something like, you know, fancy RGB lights or something, or I don't know, maybe something a bit more software-y. So learning, because I have to use C++ for this, but I'm using like the Arduino C++, which is not real C++, so it might be good to kind of learn the real thing. And yeah, this has been, you know, the big thing, so I haven't thought past the end of this project yet. The end's only really just in sight now. But yeah, don't know what comes next. What projects have you worked on if you've had large projects, but it's not kind of electronicsy based or coding based, you say? Kind of go hand in hand. Drawing, oh nice. I'd love to get into that, but I don't really have much of a mind's eye, unfortunately, so it's hard to visualize and kind of feel what I'm doing. Just kind of can't picture it enough. Big portrait's amazing. How long do they take you on average then? I'm hoping not 5 years like this project, but yeah, it obviously depends on the subject, but a few weeks or something like that. Big obstacle. Yeah, big obstacle. I mean, yeah, if you can't kind of picture the scene that you're trying to do, I mean, a lot of my things just end up looking a bit oddly proportioned because I can't kind of visualize the whole scene. I'm much more focused on that one part that I'm doing right then and there, which then doesn't line up with where it needs to. Yeah, I think there's a big difference between kind of beginner, you know, doing like a pose that's straight onto the camera, or straight onto the viewer kind of thing, and something that's a bit more kind of dynamic and stuff. Yeah, I mean, there's a lot to it. It seems so simple, but it's, you know, a lot of these things have so much depth to them that you pick up slowly over time. And hey, Powered Up, how are you doing? Oh, Lego creations, yeah. Easy to undo, unlike drawing, I find, so I'm sure you could kind of rebuild them easily. Right, let me tidy up a little bit. Is that like, not just kind of a sculpture, I suppose, but is it a bit more, because I know you get quite a lot of electronicsy Lego kits with motors and conveyor belts and all that kind of stuff. Is that the kind of Lego you're talking about? Right, let's have a think what I'm doing next. So, what's in my little kit? Workable cars, nice. Okay, interesting. Let's think. What am I doing? So I'm going to get distracted with a bit of planning here. So, Where will those be? I've got so many bits of kit everywhere. Room 2, when is that for me or powered up? Could be an interesting room if you've got a lot of stuff like that. Oh my god, I've got to have these pots somewhere. Where could they be? Gotta be somewhere. I'm very jealous of you then. I wish I had a bit more of a workshop setup, but I don't. Okay, I'd like these to plug in, but I'm just going to have to solder them in directly, I think. So let's have a look. Right, so these boards are designed so that connector can go in there, and that'll plug straight into the PCB, and then next to the input row there's an output row, so I can stack these boards like that, so the input on one goes into the output of the other. So I can solder them directly like that, as long as I don't make any mistakes. Yeah. And that's it really. So I will get some output connectors ready. To it, and then I'll solder these boards together. Right. And if I do it this way, what won't block the other ports on the board? Guess if I do it this way. I know you can't see what I'm doing too well, but this is just for my mental map. Okay. What games am I into? Bit of a mix of... Oh, I left my iron on. bit of a mix of like strategy type of games, so like RimWorld, which is good. A lot of variety in that, a lot of thinking, planning, so it's good. What else as well? Little puzzle games as well, so like there's fights in tight spaces, FTL, Into the Breach, which is made by the same people as FTL. Chess, almost. Into the Breach is almost like chess. It's on like a 8x8 grid, and you have to, make moves in turns. Turn-based strategy game. So yeah, that's about as close to chess as I get. I can't think that far ahead, so chess has never been my strong suit. As you can probably tell, I'm going to make mistakes in this, despite having thought about it. So chess isn't my kind of game. Okay. Fairly easy to solder a row of headers on. There we go. It is a bit squint, but I think I've ruined that now. Okay. Not hard to overthink in. I haven't played chess since I was a kid. I never did very well with it, so I just kind of moved on and never tried it again. Yeah, but a lot of the kind of turn-based games that I play are similar-ish to chess, but you don't have to think that far ahead in advance. And I still make mistakes, but you're always going to make mistakes, really. Isn't going to be exciting viewing at the moment because it's not under the camera. But this is through-hole soldering, so you don't really need the camera. It's a bit more large scale, easy to see what you're doing. Okay. Like Tetris. Yeah, but I guess you need pretty twitchy reflexes to play Tetris. Again, probably not a strong suit of mine, but okay. Right, before we get any much further on this, just going to do a quick check that I haven't got any short circuits or anything like that. Okay, this seems okay. Cool. Good board. Nice, no shorts. Interesting. That's all okay, right. Okay, happy those boards don't have any shorts on them because I don't want to wreck a segment display. I only have one at the moment. Okay, so I think I want them on that way around. It's just a couple more connectors to do now, and I'll try and get a segment display working. Nice and straight. Excellent. Well, this is on rough terrain. Let me pop it under the camera. It might be a bit too zoomed in to see anything, but at least it's a bit more interesting looking at nothing. There we go, nice. I'll stick to my fingers now, I've been pressing on it too much. Okay. So, now we'll pop this on and then combine the boards. Yeah, this is going to be difficult to see and hold down. It's a pretty awkward shape with all these connectors in them now. Okay, oh. I'll just get that straight. Great. And then do the rest of these. Attempt to tape this down. No, it's not going to stick. The awkward angle to work at. And the solder is sticking to the iron again. Come on. Oh my god, come on. Okay, that's it. Got nice flow there. Oh my god, come on. Yeah. Sorry, I just read your message there, but I got my flux pen. Yeah, I think the tip's pretty dirty, but I'm getting through it. It's just a little playlist of synthwave songs on YouTube. Video game synthwave beats. I think if you search that, you'll probably find it. It's just like old Sega Nintendo songs, but with a bit of a modern synth touch. Okay, so now I can stack these two boards. Maybe I can jam something between them to keep them. That's fine. I'll just solder them as is and then position it after the first one. Okay. So ideally I'd have a 5-piece connector for this, so I can plug them in and unplug them, but I'll just solder them directly together. Should be absolutely fine. There we go. So I'm not quite wanting to really stick. Okay, and just separate and space them a little bit better. It was really hard to do with just 2 hands. There we go. That's pretty nicely spaced. Thanks. I think it's quite a popular genre amongst the builders that are doing similar Keep Talking projects as well. Oh my god, my tip. Get some more flux on that. I never have a Nintendo growing up, but I think a lot of the songs are just so well known that I don't mind them. Doesn't have that nostalgia hit for me though, but that's fine. Oh, it still does not want to stick still. Let's tape this down a second. Okay. Hope no one's getting seasick at the amount this board's moving around. There we go. Apologies for the constantly moving PCB. It is difficult to solder and keep it in place. And yeah, just need two more hands really. There we go. Right, last one. Don't usually do through-hole soldering on this little camera thing, but it's quite fun to watch it melt and fill the gaps in. Right. So there's that. We've got our little stack of shift registers. So where's my new segment display? Here it is. Let me switch to desk. Alright, so I don't know the pins for this, but we've got 9 pins on each row, 2 rows. So these are individually addressable digits. So the other ones I've got, they've got pins, 1 for each of the 8 segments, and then 2 pins for the 2 digits, and you have to multiplex between them. So I was going to use this for venting gas, but with the venting gas, let me grab it. Yeah, here we go. So with venting gas, you've got the an OLED display in here for the main kind of display, the main window, and it takes a little bit of time to write the data to that display. So that wobbles around quite a lot. So when it's writing that, the segments can't be multiplexed on the other one. So I've gone for individually addressable ones. So I can just draw the number to both digits at the same time, and then I don't have to do any constant flickering between the 2 digits to update it. So it's much simpler. And I've got a little board to put it on, so it fits into the display nicely for my printed parts. So I just really need to get some wires between those and those, which is gonna be awful, to be frank. So I'm tempted by a little breadboard test for the moment. So breadboard out, because this will save me just having to prepare a load of wires now. That'll be another hour of time gone. So I'll just wire up these segments, and I've got to reverse engineer them as well, because I don't know what the segments link up to. Could try a quick Google of the serial number on the side. Right, let's get rid of this. Because of that, I'm going to put the soldering iron away for the night. Don't need the camera. Right. So let's have a quick look of this serial number. See if I can find something. I do actually have it. Okay, let's see if this is right then. So, which is our pin number 1? Pin 1's bottom left. Oh god, right, so I've got to translate the little spec diagram to something useful here. Okay. And I don't know how this is going to go, I'm just going to kind of work off it. So pin 1 is I suppose I could plug it straight into there. I'll need some longer wires. Most of these are short. Right, hang on. Get my other batch out. Get my other batch out. Right. And we can hook up the hook this up directly to this. Alright, so pin 1 is 4, and we're working left to right here. It's 4E, so let's pop it in number 5. Pin 2 is 4D. And I don't have any code for this at the moment. I should have something that I can reuse from before quite quickly. But I mean, this is all completely new and custom, so I'll have to write something quickly to do that. So pin 5 is E, but on the other one, the other digit, 6 is D for digit 2, 7 is G, 8. It's amazing what weird orders these 7-segment displays are done in. I don't know how they're made. There must be some kind of logic to it. It must be simpler to produce, because it would be amazing if they just went A, B, C, D along instead of whatever order this is. Okay, so 10 is B for digit 2. This display is not going to be very easy to see either, because I'm going to have all these Y's in the way, but that's fine, it's just for demonstration purposes. Well, hi Quantum, how are you doing? Good of you to rejoin. Why is it so crazy? It's not too unhinged when you look at what other people who do like electronic stuff do. And wow, this is getting hard to get the wires in. It's all a bit too compressed, which is good for a finished design, but hard when you're trying to prototype. So that was 10, 11, 12, 13. Oh, these are the digit ones, okay. Alright, so those are the digit ones, 13, 14. And then back to the segments. So 15 is 4B. 16 is 4. I got tied up knots here. Yeah. Oh, we're done. No, we're not done. There's it's not 16. There's 18 pins. So 17 is 4G. I really hope this circuit diagram is right, this schematic is right, and I'm not just wiring these up completely incorrectly. But there we go, so that should be what I need. Oh, right, okay. I'm doing fine. A lot going on. Trying to find a bit of time for this project at the moment. Not as much as I'd like, but yeah, I mean, it's going along fine, so motivation's still pretty good, which isn't too bad. But yeah, generally okay. Hoping to keep that energy level up. It might wane at some point. Right, we'll use this one. So I think I can plug that straight into my board like that. This is not really going to be very easy for you guys to see, unfortunately. Sorry about that. There we go. And then on this board, I need this programmer. Okay, so first stage is to plug it in and see if it explodes. So hopefully there's been no... Actually, I'll I'll boot it up without a 7-second display, because if I lose that, I lose my only ability to do this right now until more turn up. Let's plug this in and see if it is fine. Okay, perfect. Right, so now I need to do a little bit of coding. Tidy up the desk. And try and get these 2-segment displays to work. Right, so I'll also need to plug these 2 digit wires in. Where will I put these? Okay, that's fine. So what am I going to do? Let's alter the code for preventing gas. That makes sense, because this should hopefully be exactly the setup. Apart from probably a couple of pin changes, because this board is quite old in terms of the design. So programming modules. Needy modules, and we've got the venting gas code already. Okay, let's move this off to the side for just a moment. I'll plug this in as well. I trust it's not going to explode at this point. Okay, so let's get writing some scripts for it. Oof. Right, so I think I had something similar in some old code for this. Shift display. Now I need to think about how that works. How did that shift display module work? Let's have a look at an example. How does this work? This song specifically, so it's in a video game synthwave beats thing on YouTube. It is Pokemon Gym. I hope it didn't take me too long to read that question, Quantum, because that might be the next song. Okay. Oops. Okay, so if you can bear with the awful OBS setup, I can... Yeah, you recognise it as the gym soundtrack now. No, a lot of these are very familiar, but hard to think what they are. Alright, yeah, so that's my desktop and desktop as well. Okay, perfect. Right, so you can see a bit of code now, hopefully. Now let's think, how does this work? So let's decipher this library again. To do some setup. Display, where is this set? Shift display. Okay, so you initialize this library, and then what do? What are the methods to this? What is this? Public method set store value to the buffer. And Okay, interesting. I'm gonna quickly. Well, that's fine. I'll just make something up. I think there should be commented code here that I can still use. So shift display. Kind of like a display. Ooh, I might have deleted too much of this. I think I should be able to reconstruct it. Shift timer, there it is. Shift timer. Lines and lines of code, I know, right? So I think I need to call that library again. Shift display. And then again at the bottom of this. Shift display. With timer. Right. Oh my god, I never did computer science, but that's crazy. I guess I can understand why. It's more about thinking and learning rather than relying on the computer. But you know, when are you going to be writing code without, you know, Stack Overflow or help from the software itself to kind of suggest the methods and stuff like that? So what's in the shift display thing? I think there's a few ways you can initialize it. Yeah, with some custom pins. I can't remember all what the pins are. I haven't labeled them in KiCad in terms of what the latch, and I'm pretty sure the first one's the data one. But yeah, I don't know which 4 and 5 are. So let's have a look. Oh my god, what are even the pin numbers? Alright, sorry. Sounds all kinds of awful, I know, right? It's just a lesson in torturing, I think. Alright, so sorry, I've got a mess on my desktop here. So let's have a look at the pins. Unless I had them somewhere. Sorry, I'm all over the place because I wasn't really intending on doing this. Bless me. Oh. I can't say it was fun. Yeah, I would not want to do that. I'm sure it'd be more comfortable now after I've done years and years of this, but as a student, if I was new to it, I would not want to be doing it. Okay, so I want GB. No, I don't know why I'm sneezing now. GBIO 33. Is that? I'm trying to figure out what I've plugged it into because it's going to be different to what it will be on the board. Is it? Actually, it's not. Thanks, Quantum. So I haven't fully figured out what I was going to be plugging into where on my PCB for this venting gas module. So I'm just trying to remind myself of what it is that I was intending to do. It looks like I'll be plugging it in where I have actually plugged it in on this board. Let's have a look. Oh no, not quite. Okay, okay. So there's a bit of overlap, but not the same connector. So data is 32. The latch, I presume, will be 22 and 21 for the clock. Although that might be wrong, so those two could be wrong. And then I've got the 2-digit ones, which are plugged into 1 and 2 on SPI 2. So what's that? 23 and 18. So 23 and 18. So let me switch back to wherever OBS is, to my computer. Alright, so I think I've got this set up to what I've got. Hopefully I don't have to plug in the OLED display as well, because I don't want to have to pull that module apart for that, so hopefully it doesn't try that and then stop. Should I even do it in this module? Should I try to... I think I might have a blank project where I was testing this. Alright, 2 seconds again. Open folder. I'm such a mess. I've not planned this whatsoever. So did I have a test folder? It looks like it was testing stepper motor. Interesting. Okay. Well, I don't need that, so let me... Oh, there is a segment bit in here as well. Excellent. Okay, so it's not just the stepper motor bit; it is the segment test as well. I might have 2. Shift register LED array. No. Okay, the 7-segment display. Perfect. Right, where are we? Where are we at? Okay. So I did have something here. I already forgot what I had as my pins. So data should be 20. Yeah, okay, that's correct. But D1 and D2 are 23 and 18. Okay, so those should be right. Now I'm not using the display library that I want to use. This was something I was trying to do to avoid that. So let's import that. And then we need the object itself, timer, and then we have to give it the info. Which is latch clock data. Latch clock data. And then the display type and display size. I don't know if it's common anode or common cathode actually, but we'll try one and then try the other. And it's a 2-digit display. Right, let's try and figure out how this works. So, let's try and use this if possible. We'll write both of the digits because they will always be on. They just will always be on. We've got dedicated segment lines. That's fine. So all of these functions can change really. I don't have to use them whatsoever. So instead of all of this loop stuff, we can use the shift display methods. Show book value on display. This is interesting. So I don't know what the difference between set and show is. They seem almost identical, except I guess I don't know how you can write to the buffer and not show it though. What's a section display? Custom pins section display. That could be if one or more shift registers are doing both the segments and the digits. I don't know how to use this. I've used this library a little bit a long time ago and I'm trying to remember how it works again. Right, we'll just give something a try. I think it should be show. So we can say how much of this can we use again? Yeah, some of these are really interesting. Little tunes. So I don't need a duty thing because I'm not controlling that. I'm just writing to the display. So I need to use show. And I think I can do it here. Shift timer, sorry. Show. And there's quite a few things I can show. Show a value for a time. I don't want to really show it for a time, I just want to write it. Alright, let me go away for a second and think about this library. I'm going to have to look it up. I'm going to have to do a bit of research on this. Oh no, that page doesn't exist anymore. Oh, that's bad. Okay, so the link to it in the library doesn't work anymore. Where's this library? So for driving 7-segment displays, use the whole display as one or separate by individual sections, blah blah blah. Okay, I don't know if I can use this library. I think I just need to write something custom. I think I just need to write something custom, which is fine. That's just a bit more work. But I should have something close to what I need here already. So I set up the pins. So instead of this function, I'll write another one. Void seg shift. Right, so let's take, I guess just an 8-bit number's fine. So we want to show the time, and that's probably a bad name for it, right? Is that a protected name? Timeout. So we need to do the segment shift out, something like this. So we toggle the latch. Oh, we need to do bytes. Do I have a lookup somewhere? Apparently I do have a lookup table, okay. So we need to do 2, because we've got 2 shift registers chained together. So I can kind of write the first digit and write the second digit. I think the old function's actually perfect. I think the only difference I need is that I'm not cycling between the digits, I'm just writing both of them at the same time. So I need to have 2 shifts out. So I'll have a shift of byte 1 and byte 2. Okay. Unsigned integer for the time to display the timeout. And what is digit? Okay, get rid of that. Sorry, I've gone pretty quiet because I'm trying to concentrate on what I'm trying to write here. So let's do some comments. This will help. Digits, tens, digits, unit. So we need to figure out what our tens unit is. All good. It's pretty chill in here. You just listen to the music, I suppose. I'll keep my mouth shut and you can enjoy that instead. Right, much simpler than it was when I was having to write each digit alternately. I think that's perfect. So we need to now give this function the time. So I think every second we are in this if statement, so I can give the function there. So every second it will update, and we need to write the display timer, I suppose. So that's the number we want to write. Perfect. That just goes all the way down until the display timer is 0. And then, to be honest, we can just write 0. Because you don't have to do anything special. You can just do that, I think. Right, so let's try this. Let's go back to the desk so we can see that. Just upload the code. Hope I'm on the right COM port. No, I'm not. Okay, upload the code. Fingers crossed we get something coming up on the display here, but it's possibly we won't because I've got the wrong pins, or it's a common cathode instead of a common anode. Let me see if I can get that spec sheet up again. Common anode, I think. What have we said? I think we said common anode as well. Okay. Or we can flip that. Ah, yeah, oh, that's right, that's right. Let's do a couple of voltage checks. Zero volts, good. Oh, that's interesting. I forgot that that's the 3-volt power line. Should still be fine. I don't think it needs 5 volts to work. Let's check our pins again. So, got it plugged into the I2C bit, so that should be 32, and 22. Oh, I'm using the wrong pins. Yeah, that'll be why it doesn't work. How does that board look again? So I've got so many things to keep track of: the schematic, the code, a little spreadsheet of what my pins are doing, and then the other schematic, not just of the PCB but of the segment display. So I want to be using 32, 22, 21. Alright, let me update the code. 22, 21. Okay, let's try that. It's easy to say the wrong pins should be used. Okay, upload that. Maybe we'll get something turned up now. No. One more thing to try. Okay. Still nothing. Okay. Right, so what I'll do next, just to check. I've got a spare resistor knocking around, whatever this is. I'm going to check to see if this segment display is actually wired up like it said it should be. So I'm just going to directly hook it up to some power and see if the segments light up when they should. Right, what can I do? So that's that. So I need power. How should I do this? How should I wire this up? Power to there. Now I need another wire. I've got a spare wire around here somewhere. I think I'd have plenty. And the likes this, I'm sure. Oh, I can use this actually. And what we can do is just try and get it to light up. Let's take this out as well, just so we don't get any shorts. Okay, I'm not getting anything lighting up. So why is this not lighting up? It's not a good cable. Absolutely nothing is lighting up on this thing. Okay, let's swap that. Okay, swap the polarity, still nothing. Okay, so I guess the schematic I have is garbage. So I need to figure out what the pins are, basically. So this would be an interesting little experiment. to have to go through all of these pins and just get something to light up. Oh, there we go. We got one. We have one lit up. Okay. Okay. So that's not garbage. This sequence sort of makes sense to me, I think. Was that what we had? So that's pin 5 is E, D, G, C. Yeah, okay, so that's, no, the schematic was right. However, was that correct? I changed the polarity on this anyway, so I'm really confused what I've done wrong for this not to work the first time. Okay, let's plug it back in. So the digits have to be high voltage, and the segments low. So I might have to. Well, even if it's inverted, that would show something, so that's fine. So for on, these need to be high. Just change the code to turn the segments on. And let's give that a try. So it might look wrong, it might be inverted, but that doesn't matter. Just getting something written is what we need right now. Make sure the boards that I've made work. There we go, we've got something. And it does look somewhat inverted because it's ticking along. Well, it was ticking along, but then it's garbage. It doesn't make any sense. So let's have a think about what's going on here. So it's not recognizable, inverted or not. Okay, so this could be a problem with my latch and clock pins being the wrong way around. Let me change that, because then that wouldn't be updating the segments correctly. And we've still got that. That hasn't changed. Interesting. Ricardo, what am I doing? Well, at the moment I'm trying to get my little breakout boards with segment displays, with shift registers to drive my segment displays. But the overall goal is to have it working for my Keep Talking game. So implementing the Keep Talking on Nobody Explodes video game, which for this module has a segment display at the top. So this is the last part of the puzzle for this module to work. You can see my other videos if you want to know more about the project, because there's a lot been going on, a lot to it. Happy to answer any questions, but a bit hard to just give you the full dump of everything at the moment. Okay. So let's do some serial prints, because this is what I default to, not being that good at having a good like debugging capability. So I just write stuff to the serial, which is fine. let's start with that, I think. And then let's print these numbers that I'm trying to print. Oh, thanks so much, Ricardo. Yeah, appreciate it. And as I was saying to some of the guys earlier on, it's really motivating to hear people enjoy what I'm doing. So, excellent. I mean, hopefully in the next few months I'll have this all ready. I think it does work with what I've built so far, but I wanted to get enough of the modules made, and then put it all together for a test. So yeah, that's where I am with it, really. Got any questions? Yeah, happy to answer. But yeah, just trying to get one small part of the puzzle ready today. Right, let's see what I'm trying to actually draw here. Okay, so it's counting down correctly. It's picking the digits out correctly, but then it's not drawing it to the shift registers correctly. So why is that? Let's have a look at the bytes. Which again might need to be inverted because this is common anode. I still think I've got a problem with the pins. I think I've done something wrong with the pins, but we'll have a look. Alright, what does the serial monitor say? What am I doing wrong? That seems right again, but again it's not updating this. Okay, I'm gonna have to take a look at the... Actually, will it be in my schematic, my PCB schematic, rather than the layout? We're going to the schematic. What will it say? Nine is oh, of course. Okay, so 14 is data, so that's fine. I know which one the data pin is, definitely. And then we've got 11 and 12. SR clock, R clock. God, there's so many different types of terminology for this. Right, let's have a look. Is the latch. So the what's my so the furthest right one is the latch. So I'm just thinking to myself, so $21 should be the latch. And that's where I got my code. So what is going wrong here? Interesting. Still can't figure out what I have done wrong with this. I know it's going to be something simple. I've had something similar happen when I've done stuff with shift registers before and just got the pins incorrect, but yeah. I mean, shift registers are pretty simple. You just set the latch, write the data, and then unset the latch. Interesting. The interesting bit is that none of these are changing. And yet I know it should be. Very confused with what I've done here. Well, my channel's not looking too good, to be honest, if I can't do this. I know it's going to be something really simple as well. But I can't, this code is so simple, I can't think what is going to be the issue here. There's not something from the old attempt that is interfering here, is there? Shouldn't be. This all is so straightforward. So straightforward. There's nothing uncommented somewhere else, no. I'm quite at a loss here. This is a super simple thing. there's some ordering here that I've got wrong. And again, I haven't done anything to shift registers in quite a while, so I'm unsure what my ordering problem is here. And again, that's not an intelligible display, so I can't think what it's doing. Might have to go take a break and come back to this later. That's frustrating. And this webcam is so poor that the thing's ballooned well out there. It's actually really difficult for you to read that. See if I can dim that a little bit. That's not much better. Trying to make a yeah, just a pure webcam upgrade. My other one's sitting on top of my computer looking at me rather than down at the desk. I know, and this is the problem with this project, is if I don't finish something, it gets absolutely stuck in my brain. Okay, I'm just looking at the example here. Again, like baby example of how to use shift registers. Write the latch low, shift out the data, and then set the latch high. And it's just that simple. I don't understand how I could be doing this wrong at all. Oh. Aha. Write the clock pin high to begin with. Perhaps. Register shift bits on upstroke of clock pin. So you write the data pin low, write the clock pin high. Nothing really about the latch, which is fine. What is this shift out function? So it's literally write to the data pin, clock pin high, clock pin low. Well, I cannot think what I'm doing wrong here. That's so bizarre. I mean, the fact it's not even changing over time, though. You'd expect it to be changing even if it's displaying the wrong thing. So I'm very confused. Okay, I'm just going to try writing one shift at a time rather than two. So again, identical output there. Identical output. Okay, let's think about this a bit more. Ooh, 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 ooh. In an unsigned 8-bit integer should be fine, right? Because I mean, it's literally 0 to 128. I'm not doing anything with a decimal point. Oh, 0 to 127, sorry. Let's change that anyway. Alright, yeah, cheers checking in, Ricardo. Take care. And yeah, maybe I'll check out the other videos another time. If I ever get there. It's absolutely frustrating. I'm probably going to have to go soon as well because I'm getting too tired of this. This has been frustrating. I hope it's not a soldering problem. I don't think so because it'd be odd to get any kind of display there at all. And still that. That's just interesting. Okay, I wonder, let's make sure the latch is set low before initializing the other pins. I'm just worried that it's defaulting to high or something, and then it's like starting the cycle of writing to it, which would then interrupt all further bits that go into it. Very interesting though. It's always given the same set of symbols. Same set again. Okay, let's try something else. Shift out. Date the clock. 255. Let's just shift out 255. Just a full 8 bits. And then we should see a different pattern here at least. So interesting. Same pattern. So it's definitely not in the shifting out function that we have a problem, but it is something in the setup. Something that's interrupting this shift register from working. Hell if I know what it is. Absolutely crazy. Right, I wonder if there's an example I can just like literally lift in. What could I do? Right, I'm going to try and get this done later. I need a quick break, so I'll stop the stream there. But yeah, thanks for watching. Another frustrating one, unfortunately. But that's how it is. I'll get it done though, and then get blending gas finished. And I guess the other ones in the future, they all have this common display at the top. But anyway, yeah, thank you very much. Yeah, cheers for checking in, Quantum. Take care. I know I'll get there. I've had a similar problem before. It's just been so long since I've used these that I can't think what it is. But yeah, I'll figure it out. But yeah, catch you later.